So something you people don't see is that I probably record twice as much stuff as I post, because I'll come out here, work on something, and either give up on the project or give up on filming it because it takes a lot of time and energy to do that, and sometimes I just want to get things done. And so I'm starting this project. This is the Boneyard, and this is what salvageable pieces of those projects I can find and post. So, yeah. So a while back, I was given this test set by the same guy that's given me a bunch of my cool telecom gear acquisitions as of late. So a while back, I was given this test set. A while back, I was given this test set. It's a Northeast Electronics TTS 26B pulse test set. A while back, I was given this test set. It's a A while back, I was given this test set. This is a Northeast Electronics TTS 26B pulse test set. Pulsing? Final one. A little while back, I was given this test set. This is a Northeast Electronics TTS 26B pulsing test set. And it's something I don't have a lot of use for, but it looks really cool. When I open it, you will probably agree. So being the sucker for the eBay make an offer feature, and also the eBay international shipping program, I decided that I really badly needed to have two of these. But there's a reason for that. It's not just pure test equipment gluttony. Let's take a look. Bitched at it. Oh, little battery. So here's the first unit that I was given. Let's go over the anatomy of this system a little here. So this is actually the TTS 26B test set itself, this lower half. This is the lid. Sometimes the lid has nothing in it, sometimes the lid has stuff in it. In this case, the lid has stuff in it. So the test set is meant to be used... This test set is meant to be used to test pulsing, as in pulse dialing, and it's used to test. So this test set is used to test pulses, as in pulse dialing. It's used to validate and So this test set is used to test. So this test set is used to test pulse dialing. Its primary use would be with repeater circuits or carrier circuits, where you've got DC pulsing coming from a telephone or telephone exchange being converted into out-of-band signaling, or being converted into something like DX or SX signaling, which could potentially alter the pulses. It doesn't take much to change, especially the ratio. The rate of pulsing is a bit more of a difficult thing to modify, but the ratio is very easy to get out of whack. So this set has loop and E&M inputs and loop and E&M outputs, and it can be put in line with a circuit, and its main feature is this pulse per second and percent break meter here that you can use to check your pulses per second and percent break. In the lid is a TTS 26BXC4, which
is not entirely sure what that is because I can't find documentation on it, but it's got an A relay inside. This unit is packed with circuitry right to the bottom. Oh, and there's a dial, which is actually completely separate from that. The dial is just, there's a dial which is completely separate from that, but it's just convenient to use with this. So this is used to test loops, as far as I can tell. So it has different loop resistance settings you can set, so you can kind of do marginal testing on loops. Yeah, there's a blank section here, and over here is a power supply, 48 volt DC power supply, the TTS 26B XPS. So that's the first unit I received, which is in beautiful condition. It's been stored indoors and well taken care of, and probably barely used by the looks of it. Come on. Come on. Oi. Whoa. Here's what's inside unit number 2. It has the same TTS 26B here. It has the same TTS 26B XE4 there, but it has two different modules, which is a TTS 26B XP and a TTS 26B XS1. So this one doesn't have a built-in power supply, so it needs an external power supply for it to work. This unit is an automated pulse sender, so you can set it to send from 1 to 9 pulses. Why it doesn't send from 1 to 10, I don't understand. And then so you press start and it shoots out 10 pulses, and then you can reset and start and it'll shoot out 10 pulses, and you can tweak the brake ratio. And then apparently this could be remotely controlled as well. I'm not sure how, because again I don't have the manual for that. And then this unit, the TTS 26B XS1, is... Oh, I'm out of breath. This unit, the TTS 26B XS1, is a single frequency sender and receiver. So on this side is a receiver, and on that side is a sender. So you can set it to whatever frequency. So good old-fashioned 2.6 kilocycles. And that can then be connected through to the dial or through to the circuits on here, so that this can actually act as a signaling translator. So you can have loop signaling going in and SF going out, which is kind of cool. So that's why I bought this one, because it has these two other options, which I didn't see on a lot of other eBay listings of the same test set. There's a lot of them. Obviously, they all have this. A lot of them have nothing in the lid. And at the time I bought this, this is the only one with these two units in there. So, and actually the only one with this one as well. But so that's why I had to have it, because I need these things that I don't need so desperately. I haven't seen one with a power supply yet on eBay, but I've only been looking for a little while. Alright, so I'm just going to blather on this video? No. So this unit, I think it was in a humid environment because it kind of smelled a little manky. This is the eBay unit. I paid very little for it. I paid more in shipping, as Canadians do. We typically pay more in shipping than we actually do for items we buy on eBay. So any purchase needs to be well considered. So when I first received it, there was something rattling around inside the lid here, and I took these modules out, and I discovered that 2 of these jacks had basically disintegrated. The contact pile up in the back had disintegrated. So I'll show you that next. So that thing's just parked there. So let's take a look at this. So you can see those screws they're corroded. They're kind of ugly. That one's a bit better. Ow. Now I gotta make some room. To actually fully remove this requires removing a lot of screw terminal connections, so I'm not going to do that. Instead, what I'm going to do is tuck that over there, and then ever so gently attempt to extract this module. Alright, we're in. So here's what the back side of this thing looks like. I gotta switch this to auto. Oh crap. Okay, I'm in. Here's what the back side of that thing looks like. There's a circuit board full of relays. Some interesting stuff here. More relays. This is actually a how did I describe it? A ratcheting switch. It has contacts on the end here that when that thing is actuated, the little wiper steps around. So that's what controls how many digits this sends. And so the reason we're in here is because of these contacts here. Now, what I did earlier, or before, is so these need to come off. Shit. All right. Oops. All right. There it is. So I gathered all the pieces up and taped them together when I first opened this up to discover this problem, which is what these are. These are the contact stacks that come off of these, and they're just kind of mushed together just to keep the pieces from getting lost. So we'll start with one of them. I think I'm going to switch lenses. I'll be right back. Alright. The Zoomier lens on. So I just need to reattach these. So this is going to be a fairly simple video, isn't it? So I went on McMaster Car, which is also another website that is expensive for Canadians. And I bought new screws. I lost somewhere, I don't know, I have them somewhere, the screws I took out. Oh, jeez. So what happened here? Well, I'm not sure. I have a theory. So if I untape these, you know, take a look inside here. Did a very thorough job, didn't I? So the way these are constructed is alternating layers of contact springs and phenolic spacers. Here's one of those spacers. And then through the middle are these insulated tubes here, which are a bit out of focus, but to keep the screws from touching anything. So they're this big sandwich of phenolic spacers, tubes, and contacts. And this is the top one. And it's somewhat thicker. Oh. This one's thicker. Let's see if we can see it on the end, because it's the top one, so it's a spreader plate for the screws. So that's on top. So the screw heads were gone off of the two screws that held these contact stacks in. They just looked like bits of threaded rod were all that were left. And the original screws had undercut heads, so the surface under here was machined out, which I see a lot on screws meant for electrical contacts or electrical uses. But what it meant is that where the slot of the screw passed over the body of the thread, there was basically no material there holding the head on. And something caused enough force to pop the heads off the screws. So I've been talking among telephone collectors about what could have caused enough force to pop the screw heads off. So my first theory was humidity. So these are paper phenolic spacers. And paper, being made out of trees, swells when it gets damp. And this thing smelled damp when I first opened it. And in fact, you can see in some areas, it's at a site, where there's a bit of humid atmosphere corrosion going on. So my theory was that the absorbed moisture from the environment, and it swelled the paper phenolic, and the screws couldn't handle it, and because of the way they were made, it popped the head off. But other collectors, who I respect, said in all their years looking at old equipment, they've never seen that happen. So I don't know. Then my other theory was maybe it's damp and freezing, that this got damp and then it froze, and the freezing created enough force to pop the head off the screw. So I don't know, I might test that theory out. I hope these are long enough. Yes. So the new screws are stainless steel, because that's the only, in this configuration, that's all they had at McMaster, which is fine. I don't think there's anything wrong with using stainless steel. I'm just trying to make sure those are straight. And I can go down a bit. They have a very wide slot. I'm surprised this big screwdriver fits. Okay. That was an easy fix. Alright, well there's one done. I'll do the other and put it back together. I figured while I was buying stainless steel screws, I'd replace the screws holding these modules in because they were in rough shape. So they've all been upgraded to stainless. I'll show you the old ones. So here's what came out of there. I've got it turned on, and you can see those two lamps glowing. It's trying to do something. Wow, I don't know what I'm doing here. I wonder if I can see output on that thing. Let's try that. Frequency counter, which needs a power cord. Preferably one with a 90 on the end, or a small profile. Just one with a small profile. What am I doing here? Oscillator output. Now I don't have any BNC to 310 adapters. So what do we do? Probably ground that onto there. You know, I do have
Well, that's good news. The oscillator works. That's adjusting the output level. Here's the frequency, so that's 2.6, 2.4, 1.6, 1.0. And then I can turn it off or on. So that works. So back onto the frequency counter, there's at 2.6. Wonder when this thing loses lock. Filter? I definitely need the filter. It's picking up something. Probably the lights. Anyway, we'll turn the output back up. Here's 2.4. .6 and 1.0. So that's not too bad for something that's been sitting somewhere wet for the last 40 years. Well, maybe not the last 40 years, but cool. Well, this right here is proof. You get what you pay for. So the water damage down on the bottom side of the unit is much more extensive. So these relays are just completely rusted solid. All of these power resistors are split open. I don't know why. But you can see they don't like water. There's one that's just completely disintegrated. So I have the schematic for this and I have a unit to compare it to, but is it worth it? I don't think it is. But I hate having a piece of bum equipment laying around, taking up space. But this is a mess. These pots are hooped.